Hi, everyone. This video, we're going to talk about the lone divider method of lone divider for a fair division game. It's a way to generalize the divider chooser method to more than two players. So the idea that we'll get to in a few videos here is having n players where n is bigger than 2, and things can get a little complicated as n gets large, so in this video we'll take n equaling 3. And let's recall what we're trying to do here. We have a bunch of assets we'd like to divide up amongst 3 players in this case. So we're dealing with 3 players. And we want to do this in a way that makes sure that each of them has a fair share, which means that according to each of their value systems, they get at least a third of the value of the total value of the assets. All right, so let's jump in. How does this work? Well, the book goes through a few different steps or stages that that you need to go through in order to make this work. So the preliminaries are just called step 0. So this is step 0. And what is this? This is just making sure that you've made a choice of who the divider is. So, there's a divider. Call one player the divider, and then the rest of the players are going to be called choosers. In this case, there are just 2 others, choosers. Okay, great. Now, there's a set of assets here to be divided. That set of assets we're going to assume to be a continuous type. So we often think of this in terms of like a cake, or I gave an example last time of milkshakes where you could sort of pour a certain amount out. So that's the type of assets we're dealing with in this lone divider setup. All right, so what's step 1? Step 1 is called division, and this operates much in the same way as divider chooser method does, is that the one divider that's there is going to make a choice of how to divide the assets. So the divider will divide the assets into 3 shares. 3 shares. So the 3 shares are going to be of equal value because, well, according to that divider's value system, because that particular divider wants to make sure that, well, they're going to get one of these 3 shares, so they want to make sure that they get a fair share. And the only way they can do that is if, according to their value system, each of those shares is of equal value of a third of the total assets. All right. So what happens next? So this is where things get a little interesting and a little different. So in this case, or in this method, the second step is called bidding. Okay, and so what happens here? So the choosers, each of the choosers, there are 2 of them in this case, bid on the 3 shares. Make bids on the 3 shares. Well, I'll say on any of the 3 shares that are fair shares in their value system. Okay. So what does that mean? That means that if I'm, say, the one of the choosers, I look at the three shares that have been divided by the divider. And I say, well, that share is a fair share for me. That one's not, and that one is. And the ones that are the fair shares for me, I say, I write them down and I say, okay, those are, I'm going to bid on those. So that's that step. And then the final sort of step here is the most complicated one for this method, for this loan divider method, and that's called distribution. And here we're going to branch out into two different cases, but we'll talk about what goes on here. So we have a little bit of terminology of what we call a share now. And let me tell you what I mean by that. So if a share, say S, remember we have three shares, maybe I should have said that. Let's call the three shares S1, S2, and S3. Apologies. So if one of these shares, S, has a bid from either of the two choosers, call it a C piece. This is what the book calls it. The book uses an example of a cake, and so we're thinking of this as a piece. I'll just follow that vocabulary for this video, but you could think of it as a C share. And C stands here for chosen. So this is for chosen. If it does not, if not, so there's no bid on that, then we say that it's a U piece. Call it a U piece. Okay. So then there are two cases that we want to look at, and in this video we're going to look at one of those two cases. So case one is that there are at least two C pieces. And remember, this is all with three players, so at least two C pieces. And then case two, which we'll deal with in the next video, is only one C piece. Okay, so so again, we're going to look at this case one here, and see what happens. So I've kind of drawn out what could happen just generally, and we'll look at some concrete examples in a moment. So what I'm imagining here in each of these three tables here is that we have that the divider has divided the assets into these three shares, S1, S2, and S3. And then in this case here, we'll say that out of these three shares, the first player, which both of these players will assume are the choosers, the first player makes a bid on at least two of the three shares. If the player makes a bid on at least two of the three shares, then I want to say there is a way to assign each of the shares so that we have a fair division. And how does that work? Well, in this case, it's not too bad. All we do is we say, well, P2, the second chooser, must have chosen at least one of these shares as a fair share, because they all can't be less than a third of the value, because the third plus a third plus a third adds to one. So they all must be, at least one of those must be a fair share for P2, for the second player. So Well, all you do is you just choose one of the ones that P2 has as its fair share, and then since P1 has two of them, well, maybe this was the fair share for P2, but then this is a fair share for P1. And then the remaining share, S1, will be given to the divider because all three shares are fair shares for the divider. So when you have at least a single player that's chosen at least two, or sorry, bid on at least two of the shares, um, then you can always do a fair division. And again, we'll look at a couple of ways. So this is certainly a case one scenario. Um, and in this case, of course, this is going to be a C share, or sorry, C piece, and this is going to be a C piece. And well, it depends on what player two chooses for the first share. Okay, what about this second table here? Well, here, let's say all of the players choose less than two, or sorry, all of the remaining choosers bid on less than two. Well, then they bid on one. And so there's two possibilities here if they all bid on, if the choosers bid on exactly one share. And that is that the two choosers bid on separate shares. So something like this. Now, of course, you could have I had it S3 and S2, but you could rearrange or relabel the numbers S1, S2, S3, S2, you could do that. So in this case, each of them choose on a different, bid on a different share. And then in this case, they bid on the same share. This last case, we only have one C piece. The other two pieces are unwanted. And so this is kind of a situation where we're in case two and things are a little more complicated. So we're going to deal with that in a moment in the next video, but right now what we'll see is here we have two C pieces and one unwanted piece. And this is a case one. And here it's really, again, easy to assign shares to the players. So in this example, player three was chosen to be at the divider, which I think the book labels as D. And then we have players one and two, which are the two choosers. And what do we do in this case? Well, we'll assign player one their bid of S3. We'll assign player two their bid of S2. Sorry, let me move this down here. And we'll assign the divider, player three, the remaining share, which in this case is S1. And each of them get a fair share. So this is sort of very determined, this version of case one. All right, so let's take a look at a couple of sort of more real life scenarios than this abstract P1, P2, P3. So I have three people, and we could talk about either like milkshakes, or we could talk about cakes. However you want to think about this, I'll think of this as milkshakes. Now, Scott, in all of the examples I'm going to look at, is the divider. So Scott is the divider, and Jamie and Lori, they're the choosers. So Scott has no preference really for chocolate, vanilla, or strawberry. He doesn't really care. He likes them all equally. So he thinks, okay, well, I've got three shakes. There are each of these three flavors. I've divided my assets are all of the shakes. I'll divide them into the three different cups, and I'll let Jamie and Lori choose. But in this process, the first thing that Jamie and Lori do is they make bids. So Jamie is going to bid on strawberry and vanilla because 35% is greater than a third, or 33 and a third percentage points. So Jamie has two bids out there, and she's not going to bid on chocolate because that's less than 33. That's less than a third. Her preference for chocolate is slightly less than the strawberry and the vanilla. Okay, great. Lori is a little more picky. Lori really likes vanilla twice as much as she likes chocolate or strawberry. So she's not going to bid on the chocolate or strawberry because both of those percentages are less than a third of 100%. So that means they would not be fair shares for Lori. But she will bid, of course, on the vanilla because she just thinks it's the best. So we are in this situation here. Um, this is exactly a situation that we um, have had here. Oops, sorry. Duplicate this, bring this down. So this is this kind of situation. In other words, what am I saying? Well, I'm saying in this version, uh, or this example, we have a player one and a player two, and one of the players has bid on two or more of the shares. And so in this case, in this case, Jamie, pardon me. And so here, all we have to do is we have to say, well, Lori is going to get whatever. We can just say Lori gets whatever she's bidding on. So we'll say Lori is going to get the vanilla. So Lori vanilla. And then once we've made that determination, since we know that Jamie has two bids out there, there will be one that Jamie has bid on, and we give Jamie at least, give Jamie that one. So Jamie will get strawberry, and Scott will get whatever's left because they're all uh, fair shares for Scott. So this is how this kind of scenario works. Let's take a look at another version of this. And again, this is a case 2 version. So if we have the same, oops, this should be 33 and a third percent. If we have a similar version here as before, where Scott is dividing chocolate, strawberry, and vanilla, but Jamie just realized she really actually prefers chocolate and strawberry and doesn't have much of a taste for vanilla at all, then we have to kind of redo the bids here. So we'll look at this as a new situation. Scott has divided these up. All of these should be 33 and a third. I'm not sure what happened here. We'll just make this 33 and a third. So Scott's divided them up equally into three different shakes. Jamie is going to bid on chocolate and strawberry because those are both more than 33 and a third. Lori is still very picky and very much likes vanilla. She hasn't changed her mind. So the remaining ones are not bid. So now here we have, before in the last example, we had two C pieces and one unwanted piece. Here we have three C pieces. And so this example, well, it's clear that Lori only could have one possible share. In this case, it's the vanilla again. So Lori is going to get vanilla. And then what I wanted to illustrate in this case is that sometimes, you'll award a share, and you have some ambiguity. So now Jamie has two different things two different shares that she bid on, but you can just choose either one. I mean, it can be random here. So here, let's say strawberry again, or we could mix it up and we could say chocolate, say. So Jamie gets chocolate, it's chocolate, and then Scott gets strawberry. So in a case like this, um, just because it's not completely determined doesn't mean that you can't get a fair division. So each of these are fair divisions. Each of these have to do with this type of scenario where one of the choosers bids on at least two of the shares. So this final case, again, these should be 33 and a third. This final case, we have a situation where Jamie has really changed her mind and she realizes she hates strawberry, hates vanilla, wants nothing to do with them at all, and will only eat chocolate or drink chocolate shakes. And so in this case, clearly we get a bid on chocolate from Jamie. We get a bid on vanilla because Lori's kept pretty consistent, and then the remaining are not bid on. And in this case, yes, you have uh, only one bid per chooser, so there is an unwanted piece, a U piece, and two C pieces. So we're still in case one, but they haven't bid on, no single chooser has bid on more than two. But this then is completely determined. You just give the choosers what they bid on in this case. So Jamie will get chocolate. Uh, Lori will get vanilla, and Scott gets strawberry. Okay. And again, this case up here. This is this more general setup that we're looking at here. So this one looks more like this, where there's just each of the choosers only bids on exactly one, but they're not the same piece. They're not the same share. That's what we'll talk about in the next video.